So the title of the last panel is Electrification of Latvia, a Dream or Reality. Just a side note, Latvia is of course already electrified. It's not that we live without electricity, but I think there is a hidden gem in this title, and the gem is called hydrogen. Hydrogen, maybe even hydrogem, an interesting word game. So hydrogen definitely has an important role, serving as a possibility to accumulate wind energy. And of course today, since the focus of the conference is offshore wind energy, definitely we have to look just beyond just simply offshore wind energy. We have to take into consideration also the intermittent nature of wind energy. Are we willing or not? Wind is intermittent, and when there is plenty of wind, occasionally, there's probably, as we say, too much of wind, right? So we cannot utilize everything. Maybe the interconnections have limited capacity, or the capacities are already booked. So it would make no sense letting the wind turbines just be turning there in vain and simply producing electricity which is sold for minus €200, right? No, it makes sense anyway if it contributes to the energy system. But still, it would make sense to accumulate this energy, this extra energy, and to use it at those moments of the day of 24 hours, within 24 hours, which which lack wind energy directly and which require additional energy. So this hydrogen as a battery, I think it's a very prospective technology. It's already, there's plenty of commercial examples of using hydrogen to accumulate wind energy or any other intermittent energy, where you can use electrolyzers to convert this kinetic energy into other types of energy. So we also have a very good panel to discuss these things, how hydrogen can contribute to work in synergy in a way with wind energy industry and contribute to the broader energy system. And let me allow the participants of this panel introduce themselves and the organization they represent, and just as with other panels, just briefly some key messages of the organizations they represent. So I'll begin with Māris Balodis from Latvenergo. Māri, go ahead.
Good afternoon. It's a pleasure to be here. My name is Māris Balodis. I'm representing Latvenergo. I'm responsible for research and development. Latvenergo is the main energy producer in the Baltic states, especially in green energy. Last year we produced 60% share of green energy in our portfolio. We have a good portfolio, generation portfolio today. Nevertheless, our strategy provides targets for medium and long term regarding development of renewable energy. Of course, that's main part will go to the wind energy, also solar, and this hydrogen will play a significant role for this transition period, for supply security and different ways how to storage energy.
Great prospects indeed. Over to Grzegorz.
Hello, good afternoon, everyone. First of all, sorry that I participate remotely. Hope that everything will be okay with connection. I represent PKN Orlen, Grzegorz Jóźwiak. PKN Orlen is oil and gas company located in Poland, but also as Orlen Group, we have our assets in Czech Republic and Lithuania. We process about 30 million ton crude oil per year. And during last 3 years, we started developing also our energy segment. We focus mainly on renewable energy sources, new projects, and both onshore and offshore direction. And I personally am representing Alternative Fuels Department, and in PKN Orlen I am responsible for hydrogen direction. Thank you.
Thank you, Grzegorz. Aivars.
Yeah, thank you. My name is Aivars Starikos. Today I'm representing, or I'm here with two hats. At one hat, I'm Latvian Hydrogen Association, so local industry association. Basically, that's exactly our connection with Latvenergo. And same time, I'm also one of the board members for Hydrogen Europe. So there is also my colleague Daniel, who will also take the floor. So, maybe just a couple of key messages. What I would like to raise, first of all, I would like to remove this misunderstanding that hydrogen is not just standalone something. It is just another carrier which is unlocking, first of all, renewable generation fluctuations as itself and provides the opportunity to deliver energy from generation to the end use. Because this is irrelevant, or we deliver or distribute molecules or green electrons. And this is the necessary for us to make this equal understanding, therefore unlocking energy supply system and make it renewable based. And basically, as a main question, does this make sense, hydrogen and all that with wind? Yes, of course. Basically, I would say we are necessary one to each other. Because then, if we can store energy, distribute, and provide different end-use sectors, so this is basically the prerequisites to make it happen.
Great. And last but not least, over to Daniel.
Thank you very much. My pleasure to be today with you. So I'm representing Hydrogen Europe. This is the European trade group association representing the hydrogen industry. We have 360 members at the moment, representing the whole value chain, so equipment, material providers, electrolyzer companies. We have the energy companies, utility developers. We have also the logistical part, moving the gas, also the gas TSOs. And very interesting, we also have the demand. So we have, for instance, automotive industry, aviation industry, also industrial sector. So it's a very, very wide representation of the industry, which makes it very interesting as well. We are based in Brussels, and we have at the moment a staff of 35 people, which is rapidly increasing. Myself, I'm the Chief Policy Officer. I just joined a couple of months ago. I'm very happy also to be here. I'm coordinating the policy work for the organization. In terms of my message, perhaps it's just about the timing. The timing right now is the right one. Within the next 6 months or so, our different national governments and members of the European Parliament will have to take a number of very important decisions on defining the policy for the next 10 years and defining to which extent do we actually want to use hydrogen and help us decarbonize the system. But most importantly now, with the current energy crisis that we have, we've seen the sensitivity of depending on natural gas and other fossil fuels, not only just because of the emissions, but also because of the implication it can have on the prices for consumers. So we need to also reconsider the role that hydrogen can play beyond probably what has been originally thought, which is probably just for the very hard to decarbonize sectors. And we need to start looking into how hydrogen can also help contribute to security of supply. So also talking on the power and the heat sector. So I'm happy to elaborate further on this topic.
Good to have you, Daniel. Thank you. I would like to first address Aivars. Of course, one of the key issues behind hydrogen penetration into the energy system was the cost of production and how competitive it can be. So over the last year, since we spoke previously a year ago, things have changed, radically changed. I'm not speaking here even about the brutal Russia's war against Ukraine, which has opened eyes to many consumers and many governments in European countries that energy independence is just so much more than long-term gas supply contracts, right? So I think hydrogen is definitely viewed as one of the solutions, albeit currently not on a large scale, but gradually with an expanding scale, which could provide a partial solution to to how we can get energy. It can be added to natural gas already now, a certain percentage of hydrogen mixture into the natural gas, which can flow through the gas transmission system. This percentage might increase in the future, depending on technological abilities, so to say. And so hydrogen is there. You can use hydrogen in transportation. Maybe you can just briefly remind us what are the main use cases for hydrogen and where hydrogen could be most scalable. What is the market basically at which we are looking?
Yeah, good question. I would say then I need at least an hour.
No, you have only 3
Yes.
minutes now, and then afterwards extra 5 minutes.
But then maybe just briefly, the first prerequisite is this acceptance of the hydrogen as energy carrier. And thanks to the God, and we are in a situation that now we are here and we are talking. Latest developments, what I truly believe, what we need to also take a look a bit simpler on all the system. Because if we are looking for a wind industry, those guys are well developed. They are saying, hey, come on, guys, we are ready on long-term contracts, provide you energy at that cost. They are very well in this part. So they know total cost of ownership. And if we see that energy cost as a basics, I'm talking not touching the pool, because Nord Pool, this is fluctuating. But if we can look on this stable approach, then this is a matter of transforming energy. This means we can easily produce enough cheap hydrogen, losing something on the process, but we can have a heating volume of hydrogen. Therefore, start to replace fossil gases in the pipeline. And that's exactly what I'm trying to say, that, guys, what makes sense is megawatt hour, what is the cost to produce it, and then losses of transition to another sector. At the end, and of course, the limitations of the system for distribution and transmission. And then I would say this is more like engineering exercise. Does this make sense or not? But basically also looking on the big wind projects, I have shown that there was even engineers' conclusions. They said, you know, at that size wind park, we need to consider not high voltage connection to the basic grid, but let's build it up a pipeline, because then we are, first of all, solving this fluctuation issue, the balancing, storage, and also the distribution costs are cheaper, because you can see that natural gas distribution of 1 megawatt hour is cheaper than electricity distribution. So partially the answers are almost here. But coming to the point where it does make sense, I would say first use cases are already today. Maris has not mentioned, but he will definitely touch it. So decarbonization of today's natural gas consumption. So how we can replace it in correct way, not damaging everything. So this is one use cases where we can definitely look. Another is fleets or captive fleets. Those are also making sense today, because 1-2 buses doesn't make sense. But if we can talk with a public transport fleet for 50 buses, then it definitely makes sense for energy company to produce it, to distributors to deliver it, to refueling station, and at the end also based on kilometer based for fleet, it will make sense also for end users. So railways, also definitely one of the possibilities. And the trucks. Trucks are very rapidly now developing. Yesterday was an announcement from big OEMs, European OEMs, who said, we are definitely going in the direction.
Mm-hmm. So there is actually demand from other industries and other sectors of economy for hydrogen. So there are use cases probably expanding, building on the existing experience. There is one aspect which, of course, is relevant to the interaction between hydrogen production and offshore wind. Wind offshore can be quite efficient, and the big question is whether it is more efficient to produce hydrogen on the spot, like offshore as well, and transport it to the shore, or whether it's better to feed the electricity into the grid and then use the electrolyzers somewhere already as an attachment or side business to the grid, so to say, and afterwards could feed it in or use it otherwise. And I want to actually ask this question. I wonder if Grzegorz or Daniel could jump in on this question.
Okay, so maybe...
Go ahead.
Okay, thank you very much. Generally, if we are talking about this utilization of synergy between offshore wind farms and end users, I can give you the example of configuration of our PKN Orlen business and give you the examples how we can, let's say, technically join these two crucial elements, offshore wind farms and hydrogen production, because the most important topic in this synergy is to build, let's say, high scale of production of hydrogen, and key point is to find the end user for utilization of the hydrogen or based fuels produced on this green hydrogen. And in case of PKN Orlen, we have refinery assets. We also have fertilizers production. So we see quite nice synergy between the green high volume green hydrogen production and utilization of this hydrogen directly in our businesses. Why? Because today we utilize gray hydrogen as a main, let's say, fuel for our assets. On refinery side, we produce it directly from natural gas. So taking account the location of refinery, and the first example is refinery in Mažeikiai in Lithuania side, we see quite big potential of replacing this gray hydrogen for green one by electrolyzers located close to the sea, to the Baltic Sea, and taking account that refinery in Mažeikiai site is located below 100 kilometers from this Baltic Sea. The hydrogen can be transported through the pipeline in similar way like we today transport, let's say, crude oil. So this is the first example of technical solution, and this kind of solution also can solve the problem with access to the water, because if we build this technical scope that the water will be utilized from the sea, then it will be solved. We need about, let's say, 10 tons of water per 1 ton of hydrogen production, more or less. So this is also quite important issue for building the business model for realization of the electrolyzer. But on the other hand, if the refinery is located, like we have example in refinery in Płock, is located about 300 kilometers from the Baltic Sea. So in this case, it is worth to analyze possibility to install electrolyzers close to the refinery and utilize existing network of electricity. But always we need to remember that the business model need to be checked carefully, taking account all pros and cons. So this is these examples, I hope, help us to understand our approach. But we have also taken account the big potential of production of green hydrogen from offshore wind farms, especially on Baltic Sea. So taking account the full possibility of installation of offshore wind farms, also we as APK Norway see big potential of utilization of hydrogen for production synthetic fuels, ammonia or methanol, of course based on the location business model, but this direction also is quite interesting, and by utilization of this kind of products we can solve the problem with logistic, with transportation of hydrogen.
Mm-hmm. Yeah,
Thank
thanks.
you.
Yeah, thank you, Grzegorz. Daniel, do you want to add something to this?
Yes, very quickly. I think how I will put this is that today, probably most of the electrolyzers will be very close to the demand, and they will be utilized on the power grid. They need to maximize the utilization of the electrolyzers, so they will also be trying to get electricity from wherever they can to meet the conditions. But as we evolve, I think the electrolyzers are going to be also going toward the offshore environment. And I see in the mid to long term that being the most interesting solution, because you will be able to develop the hydrogen infrastructure, and you will have less of a pressure to reduce the cost of hydrogen production itself. So even if you will have lower full load hours in those environments as compared to electrolyzer, which can take electricity from all the different sources, then you will be also let's say, optimizing the cost of distributing the hydrogen, which is much cheaper to do it by a pipeline than to the electricity grid. And also, I mean, if you're talking about 100 megawatts electrolyzer, it's still relatively, I mean, it's very large, but it's still relatively small for a power system. But if we go into a 1 gig electrolyzer or 2 gigs, this is not something that the power system will be able to cope very easily. And so that then you need to also move to the different infrastructure. That's how I would see it. Then, again, we are looking into expanding massively the offshore potential, offshore wind potential. And one of the bigger bottlenecks already today, since many years, look at Germany, for example, is the connection to land. This is what takes so long. Developing a wind farm will be much faster. So if we really want to accelerate the development of offshore wind, there is no way without looking into the production of hydrogen offshore. And then probably at the beginning, you will be collecting the power from the different turbines into a platform and then transforming it into hydrogen. I think eventually you might want to produce the hydrogen also at the turbine level and already distributing directly from turbines into a main pipeline directly by hydrogen. And this something that probably will come within the next 5-6 years.
Yeah. Yeah, well, yes, thanks for your additional comment on that. Actually, I would love Māris to comment briefly on what is behind the interest of Latvia Energo in hydrogen. Is it replacement of natural gas? Is this possibility to tap into the hydrogen potential of replacing fuel for heating, or what is it exactly? Could you cast some light, please? I know that you cooperate with Latvian Hydrogen Association.
Yes, we cooperate with Latvian Hydrogen Association, which will support how to manage with different parties and make an excellent common project. But the Latvia Energo interest is use hydrogen as to make more green our CHP plants, gas-fired power plants. Our concept for hydrogen provide mix hydrogen with gas and use in our CHPs. Then also this project provide sell this hydrogen for transport sector, and also in the longer future inject in the transmission grid. And only if all three these initiatives will be successful, then a common project will be successful. And that does not matter. This electricity comes from offshore or onshore or solar or from nuclear. The main driver for hydrogen project in our case will be price difference fluctuation. Yeah. And that's very important to use these lower prices for producing hydrogen. That's one of the problematic question between renewable generation and hydrogen production, how to share the risks and investments risks regarding of all businesses.
Mm-hmm. Right. So, would you say, so we are speaking about pilot projects, right? It's testing solutions.
For longer term, we have a project target to mix 5% in our gas consumption. It will require about 100 megawatts electrolyzer capacity in our CHP. But at the same time, we have also initiatives in the smaller projects to learn about hydrogen technology. And this most likely will be some points where we use distributed wind or solar energy together with hydrogen production, storage, and possibility to sell hydrogen for transport. Maybe it will be also a hybrid solution, charging station for electricity transport, and selling hydrogen for hydrogen transport.
Let me just quickly develop one thread. You mentioned also Latvenergo is going to develop wind energy. I don't know whether it's going to be only onshore or whether it's going to be also offshore wind, but I presume that then when thinking of developing wind energy, you are thinking of combining wind energy with hydrogen, right? Is my understanding correct?
Yes. The best solution is the best optimal mix of produced energy. In the middle term, our priority is developing a wind power plant in onshore. Of course, in the longer term, our strategy provides also participation in offshore wind energy projects. But how can I say the best solution is right way to mix generation, flexible generation, and renewable generation, and storage.
Right. Grzegorz, Orlen is definitely, it's quite a big company, let's be honest, right? So it's an important player in the energy sector in the Baltic Sea region. So how much emphasis do you think on hydrogen production or on increasing the role of hydrogen is Orlen going to put in the near future? Can you set some sort of a horizon where you want to achieve like X capacity of energy production using hydrogen?
Yes, thank you for this question. Of course, this is maybe first information that we have already announced our hydrogen strategy. So the dedicated strategy for our hydrogen projects, we announced this strategy in February this year, and our approach is to first of all develop the projects of hydrogen utilization in transportation. So in this is totally new business area for PKN Orlen, taking account the new fuel. Of course, we produce these standard fossil fuels from many years, but this fuel, especially we see potential in market for municipal transport and heavy duty transport. And also we see big role of hydrogen for decarbonization of our existing assets. As I mentioned before, today Orlen Group produced and utilized about 340,000 tons of grey hydrogen per year. And our goal is in our strategy is to have at the end of this decade 50% of low and zero emission hydrogen in portfolio. So quite a big challenge, but this strategy is ready for realization of this goal. Answering directly about the question about the low and zero, let's say, hydrogen production as a new production, we are going to install at least half gigawatt of installed capacity of hydrogen production, with ambition to achieve 1 gigawatt till the end of this decade. Part of this hydrogen will be utilized for automotive. From our prediction, it will be about 19 kilotons of hydrogen. But most of these new sources of hydrogen will be utilized directly in our processes, replacing the gray hydrogen. And of course, for us, very important direction is to realize the synergy between the offshore wind farm and green hydrogen production. In area of Poland, Baltic Sea, from the very beginning of realization, even conceptual project, we take into account the hydrogen production. We did the first analysis how to implement this kind of projects, and taking account the area of Baltic Sea in Lithuania, Latvia, and Estonia. Also, we see big potential of synergy between hydrogen production, because we have Orlen Lietuva assets, Możejki refinery, which is also from energy security point of view quite important, let's say, assets for the region, not only for PKN Orlen, but for all regions. So this is the reason why we consider implementation of the green hydrogen production project, that part of this hydrogen could be utilized and replace gray hydrogen, and part of this hydrogen can give us opportunity to produce synthetic fuels, e-fuels, which we need to realize new challenges connected with Fit for 55 directives and this RFNBO goals of implementation in our fuels mix.
Thank you, Grzegorz. I actually have an additional question, quick additional question here. Well, out of this hydrogen that PKN Orlen is planning to produce in the, well, vis-a-vis the time horizon you provided, what would be the proportion of hydrogen produced in synergy with wind energy?
For our strategy, the proportion, especially at the very beginning, is about 50-50, because we need to remember that these renewable energy sources first are needed for, let's say, replacing the coal from our electricity mix. But we expect that from the beginning of next decade, when the first, let's say, offshore projects will be implemented, it allows us to, let's say, increase this proportion in direction of hydrogen produced from wind farms. Thank you.
Actually, it's interesting how well, how research and development has already, like the stage when the technology is deployed I mean, this stage of research and development is somewhere coming to an end, and it looks like hydrogen is gaining the quite steep upward slope, so to say. So it's going into mass market. It's not yet a mass market, but it's somewhere very close to becoming mass market. It's currently early adopters, or it's not late adopters, but early adopters, right? So it's interesting that the big commercial companies definitely are embracing this direction of market development. And I wonder how many years will pass when we will be speaking about late adopters, when hydrogen is going to be the mass market product. But in this context, I want to ask to Daniel if you are willing to answer to a question from the perspective of European Hydrogen Association. How much role, from your perspective, does hydrogen industry see for offshore wind in energy, in hydrogen production? So do you see it as something which is inevitable and essential, I mean, wind energy for hydrogen production, or is it just one of a number of business opportunities of how you can get hydrogen?
Okay, thanks for the question. Of course, offshore wind, or wind in general, obviously it's a key fundamental pillar for the green hydrogen production. Yeah? So definitely has a very important role to play. It will very much depend also on the rules of the game. And these rules are not yet defined. Yeah? So we are now discussing in Brussels how to define renewable hydrogen, and there is this term about additionality. You know, if you want to produce a hydrogen which will be compatible with the targets that Gregor's company and others have to meet, it needs to come from renewable power, from new power plants, new offshore power plants. And defining this, what does it mean to be new? It's part of the debate. It has to be additional. And the situation at the moment is that if you want to produce renewable hydrogen and you want to satisfy some of this demand, you need to go out into the market and get wind power. And this has to come from new wind farms, which are not receiving any type of subsidy. And if you look into the offshore sector, the lead time for projects is much longer, 6-8 years. Yeah. So all of the wind farms today offshore are developed through some type of support, some type of government-driven instrument, which may end up with a tender or with an auction. And so this will be classified as receiving support. So all these installations are not eligible for the production of renewable hydrogen. So in principle, it has a very important role, but this is about the timing, when it will be probably the first projects are going to be relying much more on onshore or mostly on solar PV, because this can be more quickly developed.
Okay.
Okay.
Yeah, go ahead. I interrupted you. I think you wanted to wrap up your thought.
Yeah, and this, well, I mean, we don't have a number, if this is what you are after. Of course, I have some calculations here and there, but that's not the answer, not the number of the association. But this is for the current target, which will lead around 40 gigawatts of electrolytes. But now we have a new story going around, and there is an ambition from the European Commission to increase significantly the amount of hydrogen use in Europe by 2030. So that will also boost significantly the need to also get renewable power, including from offshore wind. So we really need to look at this definition and to make it flexible enough to ensure that many more renewable energy producers can also participate to the development of the hydrogen market.
Yeah, great comments, actually. Switching over to Aivars here in the room. Which came first, chicken or egg? Do you need demand? I mean, does wind energy industry have to approach hydrogen industry for the synergy to happen, or is it vice versa? Or is there a fine balance somewhere? I mean, how to gain this momentum between these two technologies? What's the key aspect here? Especially if looking at a market like the Baltic states. I mean, the market is not too big. right? So either if we speak about and think about scaling up this production, then we have probably to think of a possibility to export, right, this energy. So which are the key factors here?
Yeah, there is
You
a
don't
lot
have an
of key.
hour.
Yeah, there is a lot of key factors. But one thing, maybe just before I will go around the question, but this will be part, because the point is, I would say, honestly speaking, wind industry, what they are looking for? They are looking for, if I have a generation asset, so this means I have a technical, let's name it, capacity, I can produce X megawatt hours per year. So this means, of course, if I have such asset, my interest is to sell all of those megawatt hours and most efficiently. So basically the synergy is that hydrogen is helping those all megawatt hours to put on, to
be
deliver
sold on the market,
yeah.
right?
Otherwise, the grid is not capable to take it in. You need to switch it off. So you have restrictions. Basically, hydrogen is unlocking those opportunities. So therefore, this is the one synergy. Second, definitely energy taxation directive, which is upcoming, and what all of us are waiting. This will also put a lot of clarifications on that, because basically that taxation energy should not be taxed between the process, but only at the end use. Then it makes sense, because then this is for Latvenergo, how I will deliver my green megawatt hours to the end users. If I can find the best way, then this is an engineering question. And another point or angle in all that is energy communities meaning. You know this word, we have been last year also touching that, but now also this legal framework for energy communities understanding will bring, or let's say stimulate and push it further, because then it provides absolutely different argument why wind guys should collaborate with the local society and find those synergies locally. As also Gregor mentioned, so it depends from situation to situation. Therefore, it is not like one sample. It depends how we can find this local synergy with maximum added value.
Mm-hmm. In the case of Latvenergo, for example, Maris, where was the synergy coming from? From Latvenergo or from Aivars, from the Hydrogen Association? Or was that mutual agreement that, right, well, there are two industries, one needs to become more efficient, the other one needs scaling up the business opportunities?
Yes, this is a very important question, how to involve all parties in best way and share the risks. But I was also mentioned that it's very important to develop both of these technologies. If you ask about chicken and eggs, yeah, that we should take decisions regarding large-scale wind development if we know how how we will do with excess of energy. In previous, there was mentioned about this problem about consumption, and of course, and the third way is how to deal with excess of this energy for different merge with different sectors. It's especially for transport sector and on different manufacturers. And that's why in a first step we will develop this hydrogen pilot project with about 10 megawatt capacity electrolyzers, which is fit with transport consumption near to the Riga city. And then further, we can go with some more megawatts, which I mentioned. It could be 100 or more.
Mm-hmm. Thank you. I think, well, basically, you also you avoided to answer what comes first, chicken or egg, but it sounds like, from what I've heard from Daniel, Gregor, Aivars, and Maris, I'm thinking of a chicken sitting on the egg.
Chicken farm.
It's a chicken farm, right.
Basically, you need an environment where
yes.
this chicken with egg will
yes.
be comfortable.
Yeah, so it's basically, it is indeed chicken together with the egg. So it's we found the solution, the ultimate answer to this question, which came first. So I think both came first. I think there's a parallel processes. And there's actually, as we are moving towards the end of the panel, there's a question which might actually be relevant. I think Aivars partially already has touched upon this. It's about the technological efficiency of various energy storage options in the context of hydrogen business. What would you say is a more attractive energy storage solution, hydrogen or battery system? Can you mention and compare advantages and drawbacks for both? Consider there's only 5 minutes left, right? So you have 1.5 minutes. Elevator speech.
Very quick. I would say that, first of all, battery is like a big brother and small brother with hydrogen. Those technologies are, if we are looking, it depends from application. Quickly, one sample. In the cars, if we need to talk about 200 kilowatt hours on the board for a vehicle, I would say, guys, battery. But if I need 500 kilowatt hours on the board of the vehicle just to make my shift, I would say, guys, then this is a hydrogen. So, in other words, and again, hydrogen vehicles are never driven without traction battery, so to speak. They are not comparing, they are helping each other. That's one. If we talk about energy market, I would say it depends for what you need. Because if you need for data center 150 megawatt hour backup, sorry, I know that I saw calculation of Microsoft, then this will be the hydrogen. Smaller, efficient, and cheaper. But if you need for I don't know, for frequency balancing, then it depends from a lot of factors. Therefore, there is no one answer. I would say another point, they are comparable technically. It depends from your restrictions and your needs, why you are doing that. And then you can easily calculate. It is more like you need to be ready to calculate this as an engineer, not take pre-decision. No, I don't. I'm afraid from hydrogen. No, guys, come on. This is technology which exists on the market. For example, Latvenergo have a 30 years experience with that.
Thank you. I think the complex answer sometimes is the best answer. The simple answer is not always the best answer, indeed. So I think thanks for explaining this. So it depends on the use case, and
yes.
Definitely. Grzegorz, Daniel, do you want to add something to what Aivars already commented on as we are closing into the end?
I would like to add that. If we are talking about offshore wind farms area, I see only hydrogen as a, let's say, system for stabilization of electricity production, because this is high scale of production of electricity. So I would like to only add this, and generally, honestly speaking, from the very beginning of the hydrogen market creation, I do not see, let's say, hydrogen as a storage system, but I would say that I would prefer to build the full value chain, business value chain of hydrogen, and prepare it based on hydrogen utilization in industry or other part of, let's say, economy.
Daniel?
Yes, thanks. Again, I mean, I fully agree that it depends on the use case. A couple of other examples. If you're going to do your residential PV system, you want to become kind of self-independent, then you put a battery. Yeah, if you have 3 kilowatt system solar and a 3 kilowatt hour battery or 6 kilowatt hour battery, then you're good, because the complementarity between day and night is very good. If you want to provide system services like fast frequency response next to a wind farm or elsewhere in the grid, go for batteries, because they're extremely fast and they are good for that. But then the complementarity of wind, or the variability of wind over time, is not, the battery is not good for storing energy, because it will be always saturated and not being used many times a year. And then if you look at the system perspective and energy security, which is something I mentioned at the beginning, if you have short resources of wind during winter and it's very cold and you have high demand, you might want to have some type of storage energy, and that storing renewable energy in hydrogen is a perfect solution, I think, for that case where you are trying to be also decarbonized and not depending on coal or gas anymore. So it's opportunities for both, but definitely they need to coexist, and it's not a fight between one and the other technology.
Great. So yes, thank you for the comment. I think it's actually a good way to somehow even wrap up the debate in a way. So it's not white and black and white. It's not one or the other. It's basically why we are here. It's synergy. We are talking about different use cases, different scenarios, definitely different scales for different scenarios and different use cases. So the approach is much more complex than we initially think. All right, so we produce hydrogen, we burn hydrogen, let it burn, baby. No, so it's not as simple as that. I think it's much more complex, and we even didn't manage to touch on the regulatory aspects of it. And there was a question which came into Slido, and I have to apologize. It's simply no time to expand on the regulatory aspects. But the person who sent in the question on the regulatory aspects of green hydrogen production in Latvia could probably approach Ivars individually and have a conversation about that. But otherwise, I would now like to thank all the panelists of this so-called hydrogen panel. Remotely, Grzegorz and Daniel, and in the studio, Ivars and Maris, for their excellent contribution to this final panel, which was just like last year, as interesting as always, and I think it also cast some light on the very, very interesting prospects that we have ahead of us when we are thinking of hybrid energy systems, where onshore wind, offshore wind, hydrogen, even biomass, in fact, and other types of energy production possibilities. Pardon me, didn't mention solar energy as well. They work in a hybrid system, supplementing each other rather than excluding each other or competing with each other. Because the smart system tomorrow belongs to the smart energy system, and not to use the word dumb energy system is the thing of the past. So thank you again, Daniel, Grzegorz, Ivars and Maris. And on this positive note, I would like to thank the panelists,